Hello and welcome back. I'm Benjamin Williams, and today we're still within the infrastructure section within Boson NetSim. It's pretty extensive. Most of the labs are within the infrastructure section. I always have a good time going through this section. I learn a lot every time. But today we're going to be configuring basic border gateway protocol, so BGP. We're going to be dealing with BGP. We know BGP is the protocol for how the internet works. Of course, all of our other protocols are IGPs, interior gateway protocols, but EGPs are we have BGP for our only EGP that we use in today's networks to run the internet. So, our objective for this lab, it says configure P1R1 for basic external border gateway protocol eBGP, and configure P1R1 and P1R2 for internal border gateway protocol IBGP. Confirm border gateway protocol connectivity. All right. So it says configure P1R1 and P1R2. P1R3 will not be configured in this lab. Okay, so that's good to know. And it says pod 2 has already been configured upon the initial loading of the lab. So these devices over here, all of these switches and routers are already pre-configured, and we're not going to be messing with P1R1 in this lab. So perfect. We can see our topology right here. So let's go ahead and keep on going down. We also see that we have our autonomous system number 1 that's off of these 3 routers, and then we have our autonomous system number 2 through these 3 routers on the right side, and then we see our backbone Ethernet connection right here that connects these 2 autonomous systems together. Alrighty, so it said, well, we've already read through all of the commands and the descriptions. I've already did that myself. So let's go ahead and get started on our lab task. We're going to keep our topology up here in the top left. We're going to be doing our readings top right, and we're going to be doing our configuration down here at the bottom as usual. Business as usual. All right. So lab task number 1, it says task 1, perform initial configuration. So it says configure P1R1 with the appropriate host name and IP addresses. Refer to the lab topology diagram. Assign a clock rate of 6400 or 64,000 or 64,000 to the DCE serial interface and enable the interface. All right. So on P1R1, it wants us to change the host name first and the IP address. So let's go into enable, configure terminal. Let's do a host name of P1R1. All right, perfect. We see our host name just changed. And let's give it its IP address information. So let's do a do show IP interface brief just to make sure that we don't have any interfaces configured, which we don't. So we're going to start out with our fast Ethernet 00 connection. All right, so let's go into interface fast Ethernet 00. And let's give it an IP address of 10.100.100.1. 255.255.255.0 because we're dealing with the /24 network. Let's do a no shut to bring this up. Okay. We have a loopback 0 interface. It has an IP address of 192.168.1.1/28. So let's do an exit. Let's go into interface loopback 0. All right. And let's give it an IP address of 192.168.1.1, and it's a /28, so that'll be a 255.255.255. Let's do the binary for this. I'm going to bring up my iPad, and we're going to break down the binary in live action. So I have my iPad right here. So we have a /28. So let's go ahead and write out these bits. We have 1, 2, that'll be 25, 26, 27, and 28, 29, 30, 31, 32. All right, so we have a /28, so all of these would be network bits. So we have 128 up here, we have 64, we have 32, and we have 16. So let's add all of those together. 128 plus 16 plus 32 plus 16. Let me get my calculator. Where's my... Well, I can bring up a calculator. Let's bring up a calc later. All right, well, let's do, we had 128, so 128 plus 64 plus 32, oh, I put minus, plus 16. And we got 240. So it'll be a 255.255.255.240. All righty, let's hit enter there. Let's do an exit. Let's move this iPad back out of the way so we can see our terminal better. And what was the last? We have the serial 00 interface. So it's going to have an IP address. Oh, let's go into interface serial 00. Let's do an IP address of 192.168.1.33. Let's do a 255.255.255.240. Okay. Let's do a no shut. And let's do an exit. Let's do a do show IP interface brief. All right. We have all of our. Okay, so we're seeing that our serial 00 interface is not up. Oh, and that's because we didn't give it the speed that it said. So let's go back into interface serial 00 because the question asks us to assign a clock rate to 6400 for the DCE serial interface. So we didn't do that. So let's do clock rate of 6411 Okay. And it should come up. Yep, it just came up. We just see that syslog message. We can do a do show IP interface brief to confirm. And it is now in the up state, which is what we want to see. So it says configure P1R2 with the appropriate host name and IP addresses, refer to the lab topology diagram, and enable the interface. So let's go to P1R2. Let's close these down. Let's go to P1R2. It's this device right here. All right, P1R2. Let's do an enable. Let's do a configure terminal. Oops. Conf T. And let's do a host name of P1R1. Oh, P1R2. Sorry about that. P1R2. We just seen the host name change. Let's give our IP address information. Let's do an interface serial 00. It has an IP address of 192.168.1.34 and subnet mask of a /28, so that'd be a 255.255.255.240. All right, let's do a no shut. Let's do an exit. Let's do an interface loopback 0. All right, it has an IP address of 192.168.1.17. It's a /28 as well, so 255.255.255.240. All right, and no shut to bring that up. Exit. And lastly, we have our fast Ethernet 00 interface. Let's do it. Interface fast Ethernet 00. Let's do an IP address. Start tabbing this to autocomplete. We could type a little bit faster. 192.168.1.49. And it also has a /28. So 255.255.255.240. And no shut. Let's do a do show IP interface brief. Make sure all of our interfaces are up and have the right addresses. We have .34.49, yes. And .17 for our loopback, yes. All right, everything looks good. So it says from P1R1, ping P1R2 serial 0 interface. So let's go to P1R1. Let's do a do ping 192.168.1.34. And we see our successful pings with the exclamation point. So perfect. All right, so that's done. Task number 2. It says enable basic EGP on P1R1. So it says enable EGP for autonomous system number 1. you will need to configure a neighbor statement for each pod. Okay. So it says configure a network statement for each directly connected network. So first, let's do step number 1 before we get too far ahead of ourselves. All right, so on P1R1, we're here now. Let's do an exit. All right, and let's do a router BGP for autonomous system number 1. Okay, good. And it says we need to configure a neighbor. So our neighbor is going to be, it says you should configure a network statement for each pod. So just wanted to make sure we need to do a neighbor. We need to do a neighbor statement for enable BGP and configure a network statement for each directly connected network. Alrighty, just want to make sure that okay. Yeah, so we need to do this for P1R2 and P2R1. So let's do a neighbor. Just wanted to think about that for a minute. Let's do a neighbor of 10.100.100.2. And it is in a remote autonomous system of, let me go down here to this. So it's a remote autonomous system number 2. Okay. So number 2. Enter. Let's do an exit. Oh, I ain't had to do an exit. Let's do a router. I didn't mean to exit. Router, BGP, autonomous system number 1. Oh, and we just seen our adjacency come up with P2R1, which is perfect. All right, let's do a neighbor of 192.168.1.34. It's in a remote autonomous system of 1 with us. Okay, because that's this neighbor right here. We're configuring IGP as well. Well, I don't know if we're supposed to do that now or later, but I'm just going to go ahead and do it now. So it says, because I can see for task 3, we're configuring IGP. So it says configure a network statement for each directly connected network. So we have a, let's do a network of 10.100.100.0, and it has a mask of 255.255.255.0. All right. We also have the 192.168. I could do this with one command. I just want to make sure that I'm going to configure it. Okay, so it wants it to be direct. So just want to make sure. So it wants us to do a network of 192.168.1.0, and it will be a mask of 255.255.240. All right, and we're going to do another network command for 192.168. Okay, so we did so 240. Just want to see how we would break. So it looks like we're counting in increments of 32, because that's where our bit changes right there. So it's going to be a 1.32 should be the network IP address. There's going to be 255.255.255.240 as well. All right, perfect. So it says display P1R1's BGP neighbors. How many neighbors are listed? Okay, so let's do a show IP BGP. Okay, so maybe I need to do a show IP BGP neighbor. That'd be helpful. Let's go up. Show IP BGP neighbor. Okay, so we can see our neighbor right here, our EBGP neighbor. It has an IP address of 10.100.100.2, which is this fast Ethernet connection over here to this other autonomous system. And we have our connection with P2R1 through this backbone connection. So that's what we want to see. We can see it's in remote autonomous system number 2. We can see our BGP state is established, which is what we want to see. We see we're running BGP version 4. We can see the router ID of our neighbor. So it's a lot of great information within this output. So right here for question number 4, it says display the IP BGP information. Do you see any BGP paths? Okay, so let's do a show IP BGP, and it wants us to do information. So I say a summary, or I can do paths. Okay, so let's do information. I mean, not information. Let's do summary. Okay. So it says, do you see any BGP paths? Well, maybe make sure I'm doing the right command that it wants me to do. It wants me to do a show IP BGP. Okay. So let's do a show IP BGP. All right. So yeah, we do see some BGP paths. We see this BGP path. We see these 192.168s. So we see all of these BGP paths right here. Now these right here looks like these are our BGP connections because the next hop is 0.0.0.0, which is us. So these are the BGP paths right here that we're learning from P2R1. And we can tell by the IP addresses as well, because they have an IP address of 192.168.2.0, which is different from our networks, which is 192.168.1.0. The 2 and the 1 are different, so they're in different networks. So yeah, right here, let's go ahead and move on to question 5. It says, display detailed BGP neighbor status. What is the BGP state of the first neighbor? Well, we can go back up here in our output from show IP BGP neighbor, and we see that our BGP state is established. And it says, yeah, so that's the question. What is the BGP state of the first neighbor? It is established, which is what we want to see. So it says verify EGP by issuing a ping to P2R1's loopback 0 interface, which has an IP address of 192.168.2.1. So from this router, which is P1R1, let's try to ping the other autonomous system router. So let's do a ping to 192.168.2.1, and let's hit enter. And we can see all of our pings were successful. We have 5 exclamation points, which means we can ping in, we can receive information from this router, which is what we want to see. All right. So it says task 3, configure iBGP for P1R1 and P1R2. It says on P1R2, enable BGP and configure a network statement for each directly connected neighbor. Okay. So let's do an exit here, and I want to do let me do a do show run just to make sure that this neighbor hasn't been configured on the for BGP, because if not, I have to configure the neighbor as well. Yeah, so I'm gonna have to configure the neighbor. Okay, that's fine. Just wanted to be sure. All right, let's do a router BGP for autonomous system number 1. All right, and let's do a neighbor of let me make sure neighbor of 192.168.1.33. And it is in remote autonomous system of 1. All right. Now let's do a network command. So network 192.168. Oh, and we just seen our adjacency come up with P1R1, which is what we want to see, our iBGP neighbor. Okay. So that's good. Let's do a network of it says each directly connected network. So 192.168.1.32. And it has a mask of 255.255.255.240. Okay. We also have a network of 192.168.1. It should be a slash. That's a slash. That's 1. That's 32. 16. So let me break this down in binary. Just don't want to make a mistake on these network commands. So if we have a slash 28, that means that our first address would be 192.168.1.0. Let me put my iPad right in here so you guys can see the thought process. So I just wrote 192.168.1.0. So our next network will be, if we made all of these 1, so that'll be 1, 2, 3. Well, let me just do, so that's that. So if we were to change this bit right here, that'd be 192.168. That's 60. That's 128, 64, 32, 16. That's 8. So let me see how I would, so all of those are network bits. So if I change that to a 1, let me just see right here. Let me see the network that it, okay, that 32, or that 16. Yeah, okay, so it's about 6, it's in increments of 16. And I just wanted to confirm because right here is 128, 64, 32, 16. So that's 128, 64, 32, 16. And that's 8, 4, 8, 9, 10, 11, 12, 13, 14, 15. Yeah. So yeah. 16 would be the next network statement. Just wanted to be sure. So it'd be 192.168.1.16 would be the next network statement. All right. So 192.16, that 16, it has a mask of 255.255.255.240. All right. And we want to do a network statement for 192.168.1.48 because 32 plus 16 is 48. Let's make sure. It should be correct. How do I clear? 32 plus 16. Yeah, 48. With a mask of 255.255.255.240. All right. So this did that number 1. Now it says on P1R1, configure a BGP neighbor with P1R2, which I already did. And on P1R2, configure a neighbor with P1R1, which I already did. So it says on P1R1 and P1R2 display summary BGP status to verify the neighbor relationship. So we had the syslog message, so we know that we're neighbors right here. But let's just do a show BGP summary. Oh, show IP BGP summary. Okay. Yep, and we see our neighbor right here, 192.168.1.34, which is P1R2. Perfect. And we can verify that over here on P1R2 as well. Let's do a N. Let's do N. Let's do a show IP BGP summary. And we see our neighbor 192.168.1.33, which is P1R1. Perfect. On P1R2, display the routing table. Does a route exist to P1R1's loopback network? So let's go to P1R2. We're already here. Let's do a show IP route. Show IP route. And we're looking for the loopback interface on P1R1, which has an IP address of 192.168.1.1/28. So let's look for, yep, and we can see that we have a route to that network, 192.168.1.0/28, and we can reach that via 192.168.1.33, which is P1R1. So we would be able to get to P1R1's loopback interface, and I can confirm that by doing a ping to 192.168.1.1. And we can see we have 5 successful pings. So perfect. It says on P1R2, what is the next hop IP address for routes in pod 2? So all of the networks are going, this next hop, all is going to be 10.100.100.2. It's going to go to this router and then to P1R1. So it's going to travel this path right here. Travel this path. Okay. We can see the next hop information right here as well. All right. Now it says on P1R2, ping P2R2's loopback 0 interface. All right. So let's ping. Let's do a ping to 192.168.2.17, and we are able to ping that router loopback 0 interface as well. So let's grade, see if we got everything correct. And we did on this lab. So thank you guys for watching this one, and I'll see you in the next one.